Good afternoon, good morning, or good evening. Welcome to today's webinar, How Big Data ISVs Get Marketing Data into Lakes, hosted by DataDirect. My name is Cindy Romig, and I'll be your host for today's event. Before we begin, just a few housekeeping items. This webinar is being recorded. A link to the presentation, session, and audio will be sent to you via email in the next 2 to 3 days. Also, when you join the webinar, by default, the audio bridge connected your device by the Voice over IP option. If you prefer to listen using your phone, just select the telephone option and it'll walk you through connecting over to the bridge. We encourage you to submit your questions throughout the session. We'll hold a Q&A after the presentation. You'll see the Questions tab on the right side of your screen. We'll respond to as many as we can at that time. But if by chance we do run out of time and don't get to your question, we will certainly reach out to you afterwards. And of course, if you experience any technical issues or need assistance, please enter a message and I'll respond to you as soon as possible. So, to introduce our speakers, we have Sumit Sarkar, Chief Data Evangelist from DataDirect. We are also very pleased to have a distinguished guest speaker join us today, Gary Angel. He's a partner with Ernst & Young, and he joins us. Sumit Sarkar is one of the top industry experts on open data standards connectivity with disruptive data sources. Sumit has been working in the data connectivity field for 10 years. His interests include business intelligence and data integration for SaaS apps, with a focus on standards such as ODBC, JDBC, ADO.NET, and OData. He has presented related sessions at both Dreamforce and Oracle Open World for several years. Considered one of the leading digital measurement experts in the world, Gary Angel leads Ernst & Young's digital analytics practice. Ernst & Young acquired Gary's previous company in 2013. As president, Gary led Symphonics' growth from a two-person practice to one of the leading digital analytics practices in the United States. Voted the most influential industry contributor by the Digital Analytics Association, Gary writes an influential blog and has published numerous white papers on advanced digital analytics practices and is a frequent speaker at industry events. His book, Measuring the Digital World, was just recently published. So, now it is my pleasure to hand it over to Sumit to kick things off. Sumit?
All right. Thank you, Cindy, for the introduction. So I'm really excited to present this webinar with Gary today, and thank you again for joining. I know there's a lot of webinars invites out there, so I think this is an exciting one for us, and I think it's on the front end of technology and some of the leading trends in the data and big data spaces. And we're talking about how big data ISVs get marketing data and around data lakes. So some of the background on the webinar itself, why are we targeting ISVs in this one? And obviously we see organizations as well, direct organizations on the webinar, and you'll get value out of this. But the background is that we were at Strata earlier this year in San Jose, and we talked to a lot of big data vendors, folks in the data preparation, you might hear data wrangling space, people building data pipelines, data management, all these different big data tools in the ecosystem. And a lot of these guys were talking about how do we get all the data we need, and there was a lot of discussion around data lakes and other ways to ingest data. So this is really timely in response to some of the discussions we had at one of the leading conferences. And then, why do we bring Gary on? Well, we all love Gary, but the primary reason for ISVs is a lot of times we talk to ISVs and they're building software, they're looking at new ways to go to market, and sometimes we often get the question, well, what are real people doing with this stuff on the cutting edge? We haven't yet built our software, so we're not sure what to expect. So Gary can bring some real-world industry knowledge into what he sees on the ground to help you guys, and as well as the folks on the webinar who aren't ISVs will also benefit from that discussion. And today we're going to talk about what is a marketing data lake, We'll talk about some industry trends around accessing that data from primarily SaaS applications. And we'll look at how to the mechanics of ingesting data from different open source projects. We'll mention a couple of commercial solutions as well, and how you can get data from those software as a service SaaS applications. And then we'll look more specifically at how specifically an ISV would embed these connectors into their platform, tool, or whatever they're building technology. So we'll start with defining what is a marketing data lake. This is really the definition of a data lake. It's from the SaaS Institute, which is 2 exits down from us. We're broadcasting from Research Triangle Park on the East Coast. And a data lake is a large-scale storage repository and processing engine. So you think about it as a place to dump raw data, lots of data of different shapes and sizes and structured versus semi-structured, but it's really a place to land data without much transformation. And this is a follow-up to our last webinar, which was around building a marketing data warehouse. So now we're looking at data lakes as a follow-up. And then the example of a data warehouse is more of a schema on write kind of an architecture, traditionally loaded with those ETL data integration tools. And when we look at data lakes, loaded with that raw data, sometimes you take out the T as it's landed, and we create this schema on read based on business demand or request for insights. Maybe transformations happen after it's landed. So it's a shift in the paradigm for how we support the analytics data sources that business analysts and folks are connecting to. And when we look at the benefits of a data lake, if you're not familiar with it, why are people even doing this? There's a great book from some of our friends. Actually, they're 2 exits the other direction, and Zaloni. Ben Sharma, the CEO of Zaloni, and Alice LaPlante co-authored a book, Architecting Data Lakes. And some of the benefits they talk about in there are the benefit is storing data in all shapes and sizes. So to really derive value out of the big data and really get use of big data, you really need to store all types of data in different structures, semi-structured, unstructured, etc. And it might range from things like in a CRM system, which might be more structured, to social media posts, which are semi-structured, and things like that. So we want to be able to store all that data in this lake. And then it's flexible in terms of what you can do with that schema on read we talked about. You don't have to have all the answers up front to build the data lake. You may not even have any questions, but you can store that raw data, and then you can, as questions arise and business insights are required, you can then revisit and transform and get the insights you need. And then another benefit is querying data with the SQL access or with big data programming frameworks. So this gives the organizations a variety of tools they can use, and programming languages and different skill sets they might have to really figure out what they're asking and get the right questions and answers. And then another thing is eliminating data silos. So I think that's a big thing with ISVs and organizations, is everybody talks about a single unified view of data. So a data lake is one of those avenues to get that. And we'll hear more from Gary on some of the insights on his experiences actually building some of these things out. So then the question back to, we focused really on marketing data on this particular webinar. And one of the things that we want to bring to attention at Progress Software, we know about this, we start to work more with the marketing groups with some of our technology. And it's no different with some of the ISVs we're working with from a data perspective and analytics. The CMOs will actually outspend CIOs in technology by 2017 per Gartner. An interesting trend we saw at a CIO.com is that actually Oracle, if you watch what they had a $3 billion marketing technology acquisition spree, and they traditionally have sold to CIOs, and we're seeing them gain some mind share of the CMO as well. And we're expecting to see more collaboration between those two. The technology, big data technology, might live with the CIO, and then some of the requirements might come from the CMO. And we might have been in CIO.com. We'll expect to see more collaboration. Then even in our own experience, we have public references with customers building marketing data warehouses already today. So we're seeing that happen in the real world. And our last webinar had around 500 registrations. So we're definitely on the verge of a big trend with the data analytics with marketing. And actually, Gary, you have anything to add on this?
Yes, Sumit, I really see this too. I think in the last couple of years we've seen a pretty dramatic trend, I think, where maybe a couple years back, a lot of the marketing organizations that I worked with were mainly interested in keeping everything out of IT, going totally software service, really owning what they were doing, trying to keep the IT footprint as small as possible, and in a lot of cases, really reducing or removing the amount of cooperation between marketing and IT. But the fact is, when you get into these analytics warehouses, when you get into data lakes, the technologies are more challenging, the scale is larger. These are projects that you really need IT to manage and take care of. And I think what we're seeing is that pendulum swinging back to where CMOs and CIOs really do have to cooperate more, and they're doing it. That can be a flashpoint in organizations. Sometimes they don't get along that well, but I think it's something where as these technologies evolve, we're just seeing it has to happen if you want to be good at this stuff.
All right, great. I'm glad we agreed. I had no idea if you were going to or not. All right. All right, so when we look at industry trends, I'm actually going to turn this back to Gary to share some of that insight from the ground and at EY. So, Gary?
Well, thanks, Sumit. Let's dive right in on these slides. And I guess this is a slide actually that I used to dislike pretty intensely because I worked with someone who trotted it out in literally every single presentation. So I felt a little guilty actually including it here. But in fact, it says something that is pretty important. You know, when we think about data lakes and why we go into them, one of the most appealing aspects to building a data lake is that you don't have to pre-build structure. And that's important because if you think about the traditional analytics pathway, the way most of us who come out of maybe an IT background tend to think about it is, hey, we get the data, we park it, we structure it, then we perform analytics, and then we drive decisions. But in fact, that's not really the way it needs to work in most organizations. A lot of times, you have to think about the decisions you need to drive before you can figure out what data you need to bring into the lake and what analytics you need to perform and how that data needs to be structured. And it's interesting in a lake because a lake removes a lot of the constraints around pre-structuring the data. So it makes it easier to work on the fly. But that can be a bit of a trap, too. And one of the things that I'll talk about in the next slide is the way there's a lot of different marketing data sources, and sometimes you need to decide up front the level of detail you're going to bring into the lake. Well, you know what? When you make that decision about what data you're going to bring in and what level of detail, you have to have some idea of the decisions you're actually going to drive. So even though a lake gives you a lot more flexibility about answering questions out of the data without building a lot of formal structures and without pre-committing to the kinds of analytics and the kinds of decisions you're going to drive, it still actually turns out to be pretty important when you build a lake to have some thoughts and some knowledge about how you're going to actually use it and the data and the decisions you're actually going to rely on. So, Sumit, let's go to the next slide and take a look at a little bit of a drill down into, and hey, this is probably only a small capture out of this stuff. There's lots and lots of different marketing data sources out there, and I just wanted to cover a few to give you a sense of how this data is shaped, the different ways you can get at it, and some of the implications of getting this. So metadata, marketing metadata is information about campaigns, and a lot of times this is stored in campaign management systems. Typically, it's extracted as CSV data. A lot of times there aren't APIs and there aren't direct feeds for this kind of data. Display data is when you go out and you buy display ads on the internet. This can come in a variety of different ways. Most vendors have APIs for this, which gives you high-level information about your campaigns. They have log file information because this data can get super voluminous. It can be one of the largest data sources you're trying to pop into a lake. And they can also stream the data to you. So you may see this as a real-time stream. You may see this as a log. Search data tends to be a little bit different. Search data is a little less voluminous. A lot of times you're capturing it as an API or a CSV file back from the vendor. CRM data, especially in the B2B world, but sometimes even in the B2C world, is one of the most important, one of the most complex data sources that you have to think about. A big challenge to CRM data sources out there is that unlike a lot of the other data sources in the marketing universe, the CRM data sources, even though the systems are relatively standardized, they're heavily customized. So the data you get out of these sources is really, really different for every organization that you work with. That's a big challenge. Another thing to think about if you're thinking about CRM data is that it tends to be complex with a lot of data quality issues baked into it. You know, if you think about the way, if you're in an organization and you have a CRM system, chances are you're pretty familiar with the fact that everybody in the organization uses it a little bit differently. And a lot of times there are organizational imperatives that steer maybe when you enter a lead or when you enter information on a lead or when you update that CRM system. So when you're taking CRM data into a data lake, one thing to be aware of is the complexity of this data and the potential for data quality issues. And hey, every data source out there has potential for data quality issues, but I think none of the ones I'm talking about here can be as complex as CRM data. The next two sources I'll kind of treat together, mobile and web behavior. We deal with this kind of data all the time, and there's actually, again, a variety of ways you can get it. Most digital analytics systems these days are software as service systems. They're tag-based for collection, and they can provide you with an API for getting the data. But the APIs that most vendors provide are high level, so reporting level APIs. They're REST APIs that allow you to bring in reports into the system. That's not always what folks want. A lot of times people want the detailed data out of this. So there's two different ways that you can get the detailed data. Most of the digital analytics vendors these days will give you a batch data feed. So on a 24-hour basis, they'll pipe the low-level event data to you, and you can bring that into a lake and use it. And that's a comprehensive data source. It has everything you need about people's web and digital behavior. In addition, one thing we've seen emerging in the market is some clients are choosing to stream this information directly in real time to their data lake. So if they don't want a batch system because they want to do things like real-time personalization, it's relatively easy for them as they collect this data, not just to send it off to the software service vendor, but also to stream it directly to their data lake. And so that's one thing we're seeing increasingly in the market is a focus on real-time direction and capture of behavior from mobile and web. Public social, probably most people are kind of familiar with this. There's a lot of different social channels out there, things like Twitter. Almost all of them have APIs. Some of them have direct streams, too, where you can real-time the information in. And then owned social are the communities you own on things like Facebook, or sometimes people have their own communities. If they have their own community, you really have control over how that data comes in. It might be batch, it could be real-time streamed, or it could be API. If it's something like Facebook, usually the data comes in on an API basis. So I guess what I'd sum up on this is, hey, there's a lot of different marketing data floating around out there from a lot of different sources, and this probably only captures a small percentage of the total different sources out there. But for most of these sources, there's a number of different ways you can get this data and a number of different levels at which you can access it. Sumit, let's take a look at the next slide. So one thing to keep in mind when you bring this data in is one of the biggest decisions you're going to have to make is, what level of data do I get? And one thing I want people to think about as they think about this kind of data is that in a lot of cases, you actually need the most detailed level of data. And I want to talk about why that is a little bit. You know, traditional data sources, the kind of stuff we're all used to dealing with is, hey, we have a customer record and we have a number of fields attached to that. That's really the way most data in a traditional warehouse works. And oftentimes we have a schema where there's sort of a core record that's the customer record or the account record, and then lots and lots of tables circling around that. But when you start talking about this marketing data and these streams of data, it doesn't really work that way. If you think about web behavioral data, you have this detailed stream of people who viewed page X and then page Y and then page Z, and maybe they clicked on this link and they came from that campaign, and then maybe they executed this action. It's a stream. And when you start dealing with streams of data, the actual way you work with the data changes a lot. And one really important concept that I give to people and that we've taken away from the way companies are trying to use this data is that when you're dealing with streams, the meaning in the data doesn't reside in each individual event. It doesn't mean much that a person popped open the mobile app and looked at one page in the mobile app, or that they viewed the website and they viewed it page X. Most of the meaning comes in the relationship between the events. We understand what someone was trying to accomplish by the fact that they looked at page X and then page B and then page C. And knowing what those pages are tells us a little bit about what they were trying to do, and that's really what's important about it. One other thing I want to make a point about with regard to the streams here is that when you get these detailed streams of data, like this display data or the web data or the mobile data or the Twitter feed, you can't just join them the way you're used to joining data. You know, in the old days, we had a customer record and we had a new file come in and we could match up on something like zip code or census tract or the customer ID on it. It was really easy to use those tables together. As long as we had a join key, we were set. But if you think about detailed stream data, those kinds of joins don't work so well. If I have 100 records that someone did on the web, and I have 150 records that someone did on their mobile application, even if I have a join key, joining those two things together doesn't make any sense. So the absence of equijoins is one of the reasons why when you pipe this data into a data lake, it's really important to keep the really detailed event-level data so that you can actually put the data together in ways that make sense. Sumit, let's talk about the next slide. So, boy, one big thing that I want to hammer home to folks who are thinking about building data lakes and the data that goes into them is that when you're thinking about a data lake or even a data warehouse, it's almost never for a single purpose. And we see this over and over and over again out there in the real world as people put this data together. Maybe they leave all the data at the detail level, and then they try to build reporting off of it. And you know what? The reporting's super slow, and everybody complains about it, and so they start building aggregates. Or the flip side is they come in and they say, hey, you know what? We want to build this report set, so they aggregate a bunch of data, but then people look at the reports and they say, you know what? We want to get more detail. We want to drill down into this. And I think what we've seen over time is that when you're building a data lake, you're building it as a multi-purpose tool. It's going to serve a lot of different functions. And so as you build those data lakes, it's important to think about how you support those different functions. And what I tried to do with this slide really was just to show a little bit of what I'm sort of seeing in the marketplace around companies evolving in their thinking about how data is represented in the data lake. When you're doing dashboarding, that big circle down there in the lower left-hand corner, dashboarding is a reporting function. It almost always works on highly summarized data because people want feedback right away. No one wants to run a report and wait for 2, 3, 4, or 10 minutes to get their data back. It almost has to be instantaneous for those reporting systems to work. But you know what? As you build more and more complex reports, as you go beyond your basic dashboarding, as you get into things like marketing campaign optimization, and then sometimes into reporting where you're drilling all the way down to the customer record, you can see that reporting doesn't always live at the aggregated level. Sometimes reporting lives at an extremely detailed level, maybe all the way down to individual events tied to individual customers. So I think one thing we sort of want people to be aware of as they think about data lakes is that even in the reporting world, what we're seeing is people going across the spectrum from needing highly summarized data to really get the best performance so that reports are instantaneous, but also being able to access sometimes all the way down to the detail level. And analytics, the story is almost the same. A lot of analytics really requires detailed level data. If you want to do marketing attribution, which is really critical for folks in this marketing campaign world from a digital perspective, understanding which campaigns really drove results and which touch points in combination really mattered. If you want to do that, if you want to do customer lifetime value, that's what CLTV is. If you really want to do customer experience journey mapping, if you really want to understand how customers are journeying across channels, if you want to drive personalization, those are all things that if you're building applications or lakes to support those things, you need the detailed data. There's no getting around it, and you're in a very analytic space. But there's also places where you don't need the most detailed data to do analytics. A lot of folks are a lot of times working with segmentations and targeting. They're building aggregates of the data and then using those aggregates to do things like email marketing. So a fair amount of the marketing analytics we see is actually based at a sort of medium level of customer data. Maybe not the most granular data, but more in that intermediate level of customer level data, semi-event level data, where you've aggregated the data to some extent, but it still lives at a pretty low level. And you know what? As I was thinking about this, I realized that, hey, there's forecasting too that really works on summarized data. That's analytics. When we build forecasts from a digital marketing perspective, if we're trying to help people understand how their systems are evolving or what they're going to be doing, well, forecasting does that, and a lot of times forecasting works at a fairly aggregated level of the data. So just keep this in mind as you think about your data lake or think about populating the data lake. There's going to be demand from a lot of different places. That demand is actually going to want the data to live at different levels of aggregation, probably simultaneously. It's a myth, I think, to expect that just because you're building a data lake, all the data is always going to exist only in its most detailed form. It's just not the way it works in practice. Sumit, let's go to the next slide. So one tip that I wanted to give people just in terms of how to think about, well, you know what, if I'm getting this incredibly detailed data in about how people navigate the web or the display impressions that they had out there on the web or how they use their mobile application, sometimes that level of detail is just too fine-grained for people who are going to consume the data. So if you're thinking about how do I take this super detailed level and maybe aggregate it up to a level where it can be embedded in broader applications in a meaningful fashion, where I can attach it to customer records in a meaningful fashion, think about segmentation. Segmentation is a really powerful technique. You can do this from a machine learning perspective. You can do this from a classic statistical analysis perspective. There's a lot of different techniques for segmentation. But I think the role of segmentation as a way to take very detailed data and build it up and aggregate it in a meaningful fashion is really important. You know, if you think about that web data or that campaign data, you just can't add up how many impressions someone had. When I say that this person viewed 7 pages on a website, it doesn't really tell me very much about what they care about, what they think, what they feel, what they want, what they need, what they're interested in right now. But if I can segment those 7 pages into a group of, say, early stage shoppers who are looking to research the product, then I've told marketing folks something about what those 7 pages mean and who that customer is. Segmentation is a way to do intelligent aggregation on detailed data. And that's why I want to call it out here, because it's not just an analytics technique, it's actually a data management technique. And I think that's underappreciated actually in the world of data management. We tend to think of ETL as just being filtering records, adding records, summing records. There is something else to really good ETL, and I think especially in this type of world where we're dealing with lots of really detailed event-level data, building ETL from a segmentation analytics perspective is definitely something you should be thinking about. Next slide. So this is really the last part of my side of the presentation, and I'm going to kick it back to Sumit after this, but I just wanted to talk a little bit about 3 different strategies for taking data into a lake and kicking it back to people. And the truth is that most folks I see are using some combination of these strategies. And number one is really maybe almost a traditional warehouse view of the data, not so much a lake view of the data. You take in full detailed data, you park it, you cube it, so you build it up into aggregations that are appropriate for systems like Tableau or business objects, and you build reports off of it. What that delivers to you is really good reporting performance. That's why people do this. But the truth is, it's also a pain. And it's one of the things we wanted to avoid when we first started going down the whole data lake, was we don't want to have to build all those cubes. They're very challenging to manage. They're very difficult. They restrict users' ability to get at the data the way they want, but they're performant. They drive great performance. So second option is, hey, we bring in full detail, we park it in the data lake, and we report right off that full detail. Where this works, this is the most flexible alternative for getting at the data. If you can make it performant, and if your data supports that, what that means is people can get at any date cut, any aggregation, any filter, and any combination of the data, and they can do it without having predefined structures. That's terrific. The problem is, as people explore this, we're talking very, very large data volumes here. We're talking, in some cases, very complex joins. When you try to put this data together in a data lake and you try to report on it, inevitably, you're going to find that some things aren't performant. And you know what? That may be okay for analysts. Analysts may need nothing more than number 2. But if you're taking this information and opening it up to the organization, you've got to make it highly performant. And that's why we also see people right now, I think, starting to explore option 3 here, which is taking in the full detail, parking it, but doing semi-aggregations on it. Not the kind of cube aggregations, but maybe taking it up, using those segmentation techniques I talked about to get semi-detailed levels that are still detailed data, but are aggregated up from the event-level detail. The advantage to that is you retain a lot of the flexibility of still hitting the detailed data. you still have flexibility over things like controlling the dates that you're looking at, controlling the joins, doing the filtering and aggregating the data on the fly to get what you want. And you can do that in a far more performant manner because you've done at least a 10 or 20 to 1 aggregation on the data when you've taken it out of that lowest level event. What do you lose? Well, inevitably, whenever you do aggregation, you lose some flexibility in terms of what you can do with the data. So I think this option 3 is designed to capture most of the advantages of 2 when 2 isn't performant. And truly, we see clients doing all 3 of these things in the marketplace, and usually because they have real needs that are driving to these kinds of things. So, Sumit, I'll kick it back to you.
All right. Thank you, Gary. That was a fantastic overview of what you see from the ground and trends of that space. We definitely agree with all those points, and I know at Progress we certainly have a similar view in terms of analyzing all that data, and we have our own systems we work with and try to report against with similar strategies. So when we now transition from some of the trends and strategy on these marketing data lakes, let's jump right into some of the weeds. So we'll parachute down into the actual technologies that can help load some of this stuff together. And let's set up some terms. So if you're new to some of these, the big data space, the first tool we'll talk about is Apache Scoop. And Apache Scoop it's designed to move bulk data between the Hadoop infrastructure and, let's say, structured data sources like relational databases. It's traditionally positioned using JDBC connections. And JDBC is an open standard, stands for Java Database Connectivity. And that's how it exchanges data. You can export and load between the Hadoop environment and some external data source, such as those JDBC data sources. And within Scoop, there's specialized connectors for data sources, things like MySQL and Postgres. And then there's a generic JDBC for any third party. And we'll talk about where that comes in with marketing data. And then if we go up a little bit, so Scoop is the very low-level way to actually move data in and out of the Hadoop ecosystem. And when we look at the level above that, we get into things like Apache Falcon, which is a feed management system. And it's really around some of the data lake management features and functions that some organizations are starting to run into as they build these data lakes. And its core is Apache Scoop to import and export some of that data. And while with this requirement to have some data management on top of those lakes, there are a couple different options. With Apache Falcon, there's some project that's as part of Apache. See some folks at Hortonworks are talking about it, and they have some contributors. But then other vendors like Cloudera has a navigator for some of the data governance. And then there's also standalone commercial solutions from companies like Zaloni, who we referred to earlier with the book, and Podium Data. These organizations are doing data lake management, things like data quality, data lineage, data governance, all those things. So you're starting to see that ecosystem of things being built around that. And then there's also, if you go back to some of those data integration tools that were historically maybe ETL, now they're ELT. Some folks like the Oracle data integration tools and other data integration vendors are also getting into some of this space to manage those data lakes. So we go from Scoop, and then we go up a little bit to the data lakes and with the management, and then we can talk about we get into those marketing data sources again that Gary brought up a couple of them, things like the CRMs and places to get some of the automation data from campaigns. And this is really data that's disconnected from Scoop traditionally, because we can call them siloed a little bit in the SaaS ecosystem. So if you have a healthcare data in like a Viva CRM, you might have some other data in a Marketo marketing automation system, or you might have some data in like Google Analytics or Omniture, some other system. So each of these SaaS systems and all that data is really behind an API and at different levels of aggregation when you access them, because APIs are really not necessarily designed for some of that analytics and getting that low-level detail that Gary talked about. And so to really break from that silo, when we look at how do we ingest that data directly from those SaaS applications into our data lake. And so in this diagram, in the middle, you can see we've got our big data platform, and then the bottom right is really where we're talking about. Apache Scoop is going to ingest that data, and maybe you have a bunch of different data sources. Traditionally you think of Apache Scoop, you're bringing in relational data sources, but there are JDBC connectors to all those marketing data sources as well. You got Salesforce, CRM, Dynamic CRM, Oracle Service Cloud for instance management. You can get a full view of your customer. And then you've got those marketing automation systems. You have Marketo, Eloqua, which is also Oracle Marketing Cloud, and Google Analytics. There's a lot of that data resides out in those SaaS applications, and you can actually bring that in through JDBC connectors with the Scoop, Apache Scoop project. And once you get it in there, then some of the folks on this webinar are building technology within that. So the piece that they're missing is really just that ingestion, and then their tools and technologies can then take and manage the data, do the quality, do the wrangling, or whatever it is, or the analytics within the platform. So that's where the ISVs are seeing that value of bringing this data in directly. And with Scoop, we've seen different organizations. Some organizations bringing about, between 30 and 50% of structured data with Scoop, and then maybe bring in the rest through some flat files or streaming. But this is really a way to increase some of the data movement coming in through Scoop, so you can make it easier and you can schedule it and use incremental loads. All the good things that people are doing with Scoop today to import and export. And on the left are just some of to give you an idea end to end. These are the tools that Gary mentioned as well on the reporting side of that lake. There are different tools here that I've seen commonly used. I guess I randomly picked. These guys may or may not be on the webinars, but there's a whole ecosystem of folks doing things with that data once it's in that lake. And so when we dig into actually how that JDBC access with Scoop works to those cloud applications and SaaS applications, so I blew up the diagram a little bit with my paint skills and we can see that when we have a JDBC connector to those cloud sources, what's really happening is we take Salesforce for example, and we've built a JDBC connector for Salesforce. So when you run an Apache Scoop job, you're going to pick run some query, and it's actually going to translate that query to any of those JDBC sources that you can get a connector for. In the case of Salesforce, we'll take that JDBC query, whether it's a SQL query, an incremental load, or whatever it is, and we'll actually convert it down to the APIs of Salesforce. For example, a single query we might require different APIs on the back end that we all manage, right? If you call Salesforce's SOAP API to run some SQL queries, there might be some bulk operations, some metadata operations. So we take care of all that stuff for you and put in a JDBC front end so that you can work with that data as if it were MySQL or Oracle or any other source, and gives you a really nice single interface to different sources. And this is my Geek Speak slide just to let you visualize what that would look like. And this is the Scoop command. So you can think about this. You can run your Scoop job, whether you schedule it through whatever technology, orchestration technology, but it's a Scoop command. You pass it a JDBC URL for Salesforce or Marketo or Eloqua, give it your connection information, the class name, and you're off and running, and you're extracting data from those marketing data from those silos. So it's really, that just helps visualize what it would look like. And a lot of the ISVs on the call they rely on Scoop to bring data in from relational sources. So we're expanding that thinking to marketing systems, and this is really the way to access that data sets in those marketing systems, because a lot of the time those APIs might be more for some kind of integration pattern. Maybe you're syncing things, but you really need analytics access, and that's where JDBC brings, and it's more appropriate for Scoop data ingestion. And the reason they're turning into a single interface is if you look at each of these, let's take a couple of data sources, SaaS sources, for example, you'll see a mix, like something like Eloqua Marketing Cloud has web service APIs that expose both REST and SOAP. Some of the objects are bulk, some are non-bulk. So the bulk objects would be things that you might want to pull some of those details down, like those activity records and things like that to get that big data insight. And then some are non-bulk, where you might have it more summarized or aggregated. And there's not necessarily a query language like with Salesforce. And then if we look at something like Oracle Service Cloud, there's web service APIs, but it does have a query language. It's actually pronounced Rockwell. Some Oracle people on the call can correct me if that was not right. And then there's other systems. Google Analytics is a hypercube, and you have different rules to query it. And again, Salesforce is built on, the Viva CRM is built on Salesforce, and it has a similar set of APIs. So you can see that if you're ISV, you're trying to connect all these sources and get all that marketing data out of the box, it would actually require a lot of different code paths. And so giving that single JDBC interface can really accelerate that ingestion of marketing data. And part of that trend that we're seeing, and Gary highlighted, with ETL, you're extracting data, and you're loading it and viewing it and all that good stuff. But with the new frameworks, with the big data system and the data lakes, we're seeing a lot more of the emphasis on the extract and load. So pull out data and load it into the lake. And so it's really making the data access a critical piece for a lot of ISVs, building and supporting those marketing data lakes. And to get into actually how it might work if you're an ISV and you're wanting to embed some of this stuff, we get a lot of questions around how do you recommend you engineer this kind of data access layer to get this marketing data. So for things where you pull from those systems, marketing automation, CRM, and all that stuff, you can think about those JDBC connectors, right? Before we had these JDBC connectors, a lot of these ISVs were connecting to things like SQL Server, Postgres, MySQL, and they would bundle those JDBC drivers where that orange spark is into their data access layer, and they would be able to support them out of the box. So we'll say if you think about someone like a MicroStrategy, they bundle these connectors in their analytics platform as well. And now that works great for those guys. And then when you look at in the data lakes and the big data space, it's not always the same case with marketing data. You can't necessarily bundle a REST API into your platform. So that's where building that JDBC connector and embedding that into your platform or wrangling tool or whatever it is you have in that big data ecosystem becomes really valuable to have that single interface to all the marketing data. And even beyond marketing data sources, just to give you an idea as an ISV focus, there's about 200 different connectors you can ingest data from across different APIs and versions and all that good stuff. So we've been talking mostly about marketing data, but and CRM, customer data, but there's a whole gamut of things across other big data platforms, MPP warehouses, and all the relational stuff and flat files. So there's a whole lot of stuff that can be embedded, and a lot of this stuff, a lot of the connectors that we build are really engineered for big data ingestion. So while you rely on some of the scoop connections to Oracle and SQL Server, they're not necessarily engineered for that large scale and fast data access. So there's another strategy to have a full range of connectivity embedded into your platform. And really to summarize for ISVs, what we're looking at with this approach is in taking a JDBC look at some of these marketing sources, it's really valuable to ingest that data through a single API. You can avoid some of the vendor lock-in or building proprietary things that might get outdated as APIs change. You're not necessarily using the latest, greatest API or object. And so this is part of the strategy, is to build a single API, and we deliver that through JDBC for the big data sources. We also have ODBC and OData and all that different interfaces for different types of connectivity. And then when you look at getting a single partner, we want to bring that breadth to you guys on the call. A lot of you guys are already our partners today. And then when we look at that, the dedication of having a single vendor provide that unlimited access, that provides you some security in your data access layer. Like there's a lot of vulnerabilities, like there's Poodle and Freak and Logjam and even different changes on the SaaS APIs in terms of what SSO levels they support. So it really helps support your access and lets you control that experience for your end customers. And also the unlimited support piece is a part of that partnership as well when you work with Progress DataDirect. So you can get, when you have that big POC and you need some help maybe with a certain API, that's where we can come in and help support you alongside those SaaS vendors, which we have partnerships with, folks like Eloquent, Marketo, and those guys. So that's our, we really like to work with a lot of the vendors on this webinar, or even direct organizations who've learned a little bit more about data lakes and ingestion and some of the pieces in that big data ecosystem. So I'm going to pause here and then start taking a look at some of the questions that came in.
I wanted to add to that is I think one of the real challenges in this marketing space is the fact that in the last 5 years, software service systems have become the norm. Almost every different marketing problem has a different vendor with a different software service solution targeted at that. So really people are faced these days with, one, a tremendous number of different sources, and two, a lot of differences in the way people have chosen to open up data access. And I think in general, we're seeing vendors, they're working at it. They're trying to get better. Most of them have multi-layered access where you can get reporting API access, or you can get detail level data. But oftentimes the strategies you need to hit that data are different. They're different by vendor. Sometimes they're really good and pretty standardized and robust, but sometimes they're not. And I think that's what makes this so challenging if you're thinking about a data lake on the marketing side, is that you are necessarily going to be dealing with a lot of different vendors, a lot of different strategies, and a lot of different ways the data is presented to you.
All right. Yeah, thank you, Gary. And let me take a look. So we have a question here. So I think this one might be good for you, Gary. So if a data lake stores raw and unstructured data, how do you create analytics that the business can trust to make decisions on?
Yeah, well, particularly with unstructured data, I think it's a challenge. What I see around most unstructured data, and I'll maybe stop here and make a quick definitional thing. A lot of times people talk about unstructured data, semi-structured data, and structured data in a pretty nebulous fashion. A lot of the data that I deal with is what people have termed semi-structured. It's things like web logs, so detailed event data from web or mobile applications. As far as I'm concerned, that's really structured data. I mean, it comes in a set of columns. It's just what we've always had. So it's pretty straightforward to work with. Not that there aren't a lot of data quality issues, and there are things that you need to think about when you build a data lake with detailed level data, because traditionally, even with that structured data, people are going to have, for instance, software as service systems where they see aggregations on that data, and they're used to seeing those numbers. When you get the detailed level, if they start building reports off that detailed level, well, you know what? Your numbers aren't going to tie out. We've seen that as a big challenge for people who build data lakes around marketing information, is that oftentimes if you're the IT owner or the owner of that data lake, you're responsible for making sure that your numbers tie out with a vendor who's done all sorts of complex aggregations on it, maybe won't even tell you what aggregations and filtering they've done on that data. But there's a demand from users sometimes that, hey, I saw this number in the tool. I want to see that number on my internal data warehouse. So definitely getting detailed level data can create real challenges for you in the data lake. There's no one perfect answer to how to handle that. One thing is definitely managing expectations. Be aware that if you're building your own aggregates and you have to match to some external vendor who's doing aggregations and not telling you how they're doing them, you're highly unlikely you're ever going to match their numbers. The other thing, though, and I think this gets to the heart of the question, is that if you're actually dealing with unstructured data, things like text data in particular, video data, the key to it is that before you can really use it effectively, before anybody in the business can really use it, it's got to be aggregated. If you're taking a Twitter stream in, people don't want to look at the raw Twitter data. It's too much, right? And what they want to understand is, what are people talking about and what was the sentiment behind that? That involves pretty complex text analytics. There's a lot of work getting that unstructured data just to the point where it's organizationally trustable, structured data. And that's probably the hardest step, I think, in working with that kind of data. And it's something you almost always have to do. You almost always have to build it custom and specific to the business. So definitely a real challenge for folks, and a challenge both from a data integrity and quality perspective, but also just a processing and analytics challenge when you're dealing with things like text data to get it to something that's meaningful for folks.
All right. Thank you, Gary, and thank you for the question. All right, next question I'm seeing is, what data model does your JDBC interface expose against marketing SaaS applications? So the JDBC interface that we build at Proprietary DataDirect for the SaaS sources is modeled against the data model that those SaaS vendors expose through their APIs. So while it's a JDBC connection, it's really modeled against their public data model, and we're doing things to make that analytics workload work through JDBC. We're transparently calling different interfaces based on the workload request we get. So, for example, if you're pulling some of those, Gary mentioned earlier that there's different levels of data that those systems expose, and a good example would be something like the Eloquent Marketo has the activity tables. They're very, very large, and they're actually exposed through bulk APIs And so when you query something, our driver is going to take the code path of, if you have a large query, we're going to query the bulk operations to make sure that it's going to pull from the right APIs from the back end and takes out some of that complexity from programming directly against it. Because the guys building these lakes, for traditional ETL tools, they come with connectors a lot of times, and they may not want to have to learn each new API every time they have a new source. So that's where the data models have developed.
And if you're building a data lake, you're going to want the data at the most detailed level possible. And bless the vendors who actually provide that. The ones that are going to drive you crazy are the guys who only give you higher level aggregations. And then you really have to think about, well, how do I expose this information to end users, and how do I join it with other stuff? Because you're not necessarily going to have reasonable join keys. So as hard as it is sometimes to work with detailed data, it's still a blessing when you can get it.
Yeah, no, that's a good point. We're not going to name any names today, right?
All right. No, I guess not.
Okay, good. Because they might be on the webinar. So, all right. So then next question is, so what are some of the most common big data tools that you use in your practice? That's Gary. I don't know if you want to answer that one, how you want to answer that.
Well, I guess I'll talk to this at a high level. In our practice, and I think this is one really nice thing about what EY does, is we're not a technology company, so we tend to use what our clients have, or we tend to use what we think is best in class. We have a lot of ability to pick the tool set and to tailor it to specific situations. Just going back to some points you made earlier, Sumit, we've seen tremendous evolution in the open source Hadoop technology stack, I think, both on the commercial and the non-commercial side. And if you're looking at implementing really robust data lakes, a couple years back, boy, it was challenging on these systems, even the commercial ones. I think a lot of the things that if you come out of that Oracle world, if you come out of that sort of traditional big relational database world, a lot of tools were just missing around user governance and security and data management and ETL. Most of those things have been filled in really satisfactory fashion. So we do a lot of work just in the open source stack. We do a lot of work with commercial Hadoop vendors. We also do a lot of work upstream. I mean, I think that ranges from sort of traditional statistical analysis tools. It's not like SAS and SPSS have gone away. They're still really important tools with tremendous range of statistical tools that are really convenient for all sorts of different problems. We talked a little bit just briefly about things like text analytics, and both of them have really excellent text analytics modules for doing that kind of processing where you're trying to put the data together. We use R a lot, obviously, in this environment. I think R has become, particularly among, we recruit a lot of young people in, it's what they know when they come in, and that's really nice. It's a powerful tool in this. And then you get up into the data visualization stack, and I think, again, I think some of the tools you showed, certainly we see Tableau all over the place. I mean, it's one of those companies that has just gotten tremendous traction in the marketing world, it seems like, particularly from a data visualization standpoint. So it's a really wide toolkit. I think that's a challenge to it, but it's also exciting. There's so many different tools out there. You can almost always find something that's pretty specific purposed and really good for what you're trying to do.
All right, great. Thanks for answering that one.
Well, that wraps it up for our webinar today. We have run out of time. Unfortunately, there were several questions we weren't able to get to, and we will certainly respond to the group with those shortly. Thank you again for joining us, and we look forward to having you on future Progress DataDirect webinars. Thank you again, and have a great rest of the day.